Okay, I started recording. And let me go ahead and flip back over to my slides real quick. Presentation mode, the swap. 1 second. All right. Hi, everybody. I'm Tim McAlilly. I'm here with Prashant Boyer from Northern Virginia SQL Server User Group. And we're going to jump into our session number 2 of our weekly Friday webinar. And we're going to talk to Mohammad Durab, and he's going to talk to us about SQL Server 2019 Big Data Clusters. So we're excited about that. And we've got a few things lined up for you all the way through July 24th. We're trying to plug in topics and speakers. But again, every Friday from now through July 24th, we actually started last week. We did one on Azure SQL databases. But through July 24th, we'll do an hour-long session. Sometimes it'll be packed. Sometimes it'll be just a very few people. Sometimes it'll be a healthy mix. So last week we talked about Azure SQL databases. This week we're going to talk about SQL Server 2019 Big Data Clustering. Next week, Ayman, who's also on the call, is going to talk about Azure Databricks, and he also just posted a blog post on that, and I'll get the blog link and I'll post it in the discussion thread to prepare. And then Mohammed also keeps a well-detailed blog too. And Mohammed, I believe your slides are on the blog?
Yes.
Yeah, so you'll be able to, there'll be different locations for the slides, and I apologize for that, but different speakers do different things, and that's cool. So Mohammed posts his slides to his blog, and we'll put his blog site up on the discussion thread for the slides. May 29th, you've got Jim Boreati to talk about Azure SQL Synapse, which is formerly known as Azure SQL Data Warehouse. There's some really cool features that are on the roadmap for Azure SQL Data Warehouse, or excuse me, Azure SQL Synapse that'll be coming into play during the rest of this calendar year. And then Chris Safurlis, a specialist out of the Boston area, will talk to us about Azure SQL Managed Instance. And then we're going to talk about the cloud adoption framework. We're going to kind of jump out of a database focus and talk a little bit more broadly about the cloud adoption framework for Microsoft, and talk about the framework for adopting the cloud, how you strategize and plan and prepare and train and get your organization ready for the cloud. And then I'll be back on June 19th to talk about migrating your data to Azure SQL DB or Azure SQL Managed Instance. All of this RSVP information and information about upcoming meetings can be found at our meetup site at NOVASQL. And we'll have, like I mentioned, Mo's got a long blog, so his slides are posted to the blog. Last week I posted my slides to LinkedIn, and we'll have a different place probably to go to for Ayman's slides. Again, for events that are coming up, always go to NOVASQL. That'll be a good place to find out about user group meetings, larger conferences, and things like that. Also, you can go to the Artificial Intelligence and Machine Learning meetup to find out about their series of meetups. And then we're kind of working on planning what we're going to do with the Azure Data Fest and the Global AI Boot Camps and the AI and ML Fest, but just go to NOVASQL for updates on that. And we're also, we're actually meeting today and Monday to talk about our AI ML conference with getting a date specific and a format specific, and then our Azure Data Services, whether or not it's going to be a virtual conference. It's kind of looking like it is for October or November. So just stay tuned and we'll keep you informed. I just want to say thank you for attending, and this was part of my slide deck from last week, but we're always looking for talent at Microsoft. Go to careers.microsoft.com. I think there's a bit of a hiring freeze on right now, so folks know about that. You can always hit me up on LinkedIn. You can follow me on Twitter or email me about any of the content that we've talked about or we're planning on talking about. So with that, I'm going to hand it over to Mohammed and get him started. and we can go ahead and learn about big data clusters.
Absolutely.
Take it away, Mohammed.
Awesome. Let me just make sure I am sharing the right screen. Okay, awesome. All right, everybody. Can you all see the slide?
Yep.
Awesome. I really do wanted to first of all thank Microsoft for actually putting this together. I mean, us being stuck at home for now a couple of months now, I know it can get very frustrating, especially when you want to learn new things. So I'm super excited to talk about big data clusters. That link that you see there, as mentioned by Tim, is where you'll find everything that you see here plus more. So
Hey, Mohammed,
yes, sir.
I think I messed up. Could you reshare? I'm sorry. It's on me.
Okay, no problem.
On me. I'm sorry.
No problem. Reshare screen. Okay.
There we go. Thank you very much.
No problem. Okay, good. So, like I mentioned, everything you can find there. I made this presentation in the mind that a lot of people obviously have not heard of big data clusters, and they're currently maybe a database administrator, database professional, and there's a lot of things that are new coming down the pipeline. So y'all can just sit back, relax, enjoy this session, and everything again you'll find right there. So, big data clusters for the absolute beginner. I am myself a DBA by quote unquote trade. And when I first heard about big data clusters, I wanted to present this topic to you all in a fashion where, you know, it's from the ground up, absolute beginner. Just like myself, I started to feel a little bit irrelevant, so to speak, because I'm working in the DC area majority of my life. And the adoption of new technology in the government sector is kind of at a snail pace, or at least in my experience. So how do I get myself feeling relevant, especially with big data clusters in SQL Server 2019? So we'll talk all about that. A little bit more about myself. I'm from the DC area, 20 years IT. I was honored to be part of the IDERA ACE group of 2019, if you all are not familiar with that. Online, mohammeddurab.com. And again, everything is there. This, blogs, everything. So you can just, again, sit back and relax. And if you're on Twitter, feel free to reach out at MWDurab. So the agenda, I'm going to go over, and I'm going to use quotes here with the word agenda because I like to sprinkle in stories of my experiences to kind of express and hopefully get some points across. So I'm going to be doing this roughly, talk about a history. What is a BDC in terms of the Microsoft definition? If you go to Microsoft documentation for big data clusters, what do they say a BDC is? Architecture, some features, licensing and costs, and then I'll leave you with the learning path to hopefully after you're done with this, you're a little bit passionate, excited to go try it out for yourself. So let's get started. First, the history. Now, if you all are familiar with Polybase, was introduced in 2016. Now, I do remember this time, it was towards the end of 2015. I attended actually it was a NOVASQL, a user group that I attended in 2015, and they had a Microsoft PFE, I believe. And he introduced all these new features in SQL Server 2016, one of them being Polybase, which you can sit from your SQL Server instance and using T-SQL query Hadoop sources, whether it's Cloudera, Hortonworks, Azure Blob Storage, wherever that Hadoop data or HDFS was sitting, you can query that. You didn't have to know any other language other than T-SQL. Polybase actually did that translation in the background. And I remember sitting there, this was, like 5 years ago, and I thought it was cool, but kind of in 1 year and out the other because I didn't really have anything to do with SQL Server 2016, let alone big data. And back in 2015, I was using SQL Server 2008. So this was just kind of like, oh, it's a cool feature, but really didn't affect me. And whenever I talk and I'm at a SQL Saturday and I see the attendees, I ask how many people have heard of Polybase? You got a couple hands go up. And then I ask how many people actually use Polybase, and then a lot of the hands go back down. So regardless, that was a feature introduced in 2016, so just keep that in mind. Then the year later, SQL Server made a big, huge shift. Now they actually support SQL Server on Linux. And when that came out, I remember when I first heard that, I thought, why? Why would anybody use SQL Server on Linux? It just doesn't make sense. I'm a Windows guy, GUI, click, click, next. That's my background. And now I got to look at a black bash shell. It was just too scary for me. I didn't understand why people would actually do that, let alone why Microsoft dumped millions and millions of dollars, I don't know how much, into actually getting SQL Server on Linux. But that's what happened. Big paradigm shift with SQL Server. And also as a result of supporting SQL Server on Linux, now you can actually deploy SQL Server on a container running on Linux. And we'll talk about that in a couple more slides. But that was interesting. Again, there's a big question of why is Microsoft doing this. So 2019, we fast forward to 2019, and then they had something called Enhanced Polybase. Now, this kind of caught my attention because I remember it from 2015, 16, Polybase. Now, what does Enhanced Polybase mean? This image here is from Microsoft documentation, and you see, starting from the right side right here, big data. They had the Cloudera and the Hortonworks. Now they integrated the Spark engine with Polybase. And if you're moving over to the left right here on the relational database, Oracle and Teradata and other SQL Server instances, the Oracle piece really started to own in my attention on what Microsoft is doing. I still had no idea, but Oracle. So you can sit from your SQL Server instance, as SQL Server 2019 instance, running that Polybase, Enhanced Polybase, and you can query on Oracle database. That was very, very, to me, I felt more excited about that than the initial Polybase dealing with big data, because I don't really deal with big data, so it really didn't affect me that much. But Oracle, I've worked in a lot of shops where there's an Oracle server, and then the manager comes to you and asks, hey, can you get some data from the Oracle server? And you're like, I'm just a SQL Server DB, I don't know. So this started to really entice or draw my attention. And as we move over, you see there's no SQL sources like MongoDB, Azure Cosmos DB, and then your ODBC connections. So that was what they meant by Enhanced Polybase, or you've probably seen some terms thrown around like Polybase plus, like the next iteration of Polybase. They just dumped in all these new connectors and abilities to reach out to different data sources. Amazing. They also added the ability to deploy an availability group using Kubernetes. And we'll talk about what Kubernetes is and all that in a couple more slides. But from my point of view, I've deployed availability groups and I've dealt with it. So there was a big question mark. Okay, why are they doing that with Kubernetes? I mean, it's complicated technology. What's going on? It might take forever to learn this stuff. Again, big question marks. Well, before we get into answering those, couple questions I did get when I first started presenting on this was the difference between Polybase and link servers. So again, when I talk about this and to people, I can actually see the attendees. I love to ask how many people use link servers. A lot of hands actually go up. Then I say how many people love link servers, and the hands kind of go down. Polybase has come to be that one technology for, as you see there, the first bullet, database scoped. Suitable for analytic queries, a large number of rows. But there are people, and I've actually worked in shops where people use link servers for that. So instead of link servers being used for just a couple rows coming back and forth, OLTP, they're using it for massive tables and big data warehouse scenarios. And there's a lot of problems that arises because of that. And it just becomes cumbersome to troubleshoot. So, and again, the verbiage is here for you all. If you were to download, you can go back and reference, see what the difference is, but those are the differences right there. Now let's get into the meat, I like to say, of the discussion. Is now we're going to start talking about containers and going down that route. So a container, what is a container? People have probably heard about Docker containers. And I remember when I first heard about it, this was probably a little over 2 years ago in the SQL Server community, especially on Twitter, people talking about deploying an instance of SQL Server on a container. And I remember when I first heard that, I kept thinking, why would anybody do that? I didn't connect any pieces. And now, as I say, hindsight's 2020, and I'm going to be sharing that with you throughout this presentation. A container very concisely is, imagine a service, an application, and this, let's stick with SQL Server. You have the SQL Server image file, and you take that file, so everything that's needed to run SQL Server is built into that image file, right? So when you instantiate that image using, in this case, a Docker container runtime engine, it takes that image and it runs it, it makes it a container. So the container is a running image. And the image is a file that has all of the things necessary to run that service. One quick note, when somebody says Docker container, it's like slang. It's like slang. It's like saying a Kleenex tissue. So Docker is the company. There are other companies that make container runtime engines, but Docker is one of the biggest ones, and that's why everybody kind of associates Docker with containers now, because it's just the big kahuna in the market. So that's about containers. Very plain and simple. Let's keep it simple. All a container is a running image, and you can literally pick this container up, move it to a different server, a different host, and it'll still run fine because it has everything it needed in that original image. And I'll show with some images in a couple more slides in case you're still confused. This took a while for me to actually comprehend, and even now as I present, it's like, hold on, am I saying the right thing? So now the beautiful thing about containers is you need something to take control of these containers to really expand the capability of compute, scaling out, scaling in, that type of power to take these containers, expand them if they need to be expanded, or shrink them if they need to be shrunk, things like that. Now that technology is where Kubernetes comes into play. And Kubernetes, they like to say very shortly, is the container orchestrator. Sure, you can say that. I'm also learning more about Kubernetes every day, and the more I learn, the more I realize how much it is more than just a container orchestrator. But for the sake of this discussion, it being for the absolute beginner, just look at it as Kubernetes is the brain behind container orchestration. So it can scale container deployment according to need, meaning if you have an application running on containers, for example, and during the end of the month, you have a spike in invoice processing, or you have a sale and a lot of people hit your website, you will need more instances, right, or more of these containers to handle the load or the traffic. So you can configure Kubernetes to say, if you notice, for example, CPU is being spiked above 50–60%, then deploy a couple more of these instances to handle that and distribute it accordingly. That's what Kubernetes does. So that's Kubernetes, that's containers. By the way, if you all have any questions, I should have mentioned this in the beginning, feel free to just ask. That's okay. And interrupt me, that's fine. Or we can leave it for the end, up to you all. So now Kubernetes, again, is that technology that orchestrates those containers. But when somebody mentions Kubernetes, they're most likely talking about the Kubernetes cluster. And that's what everything happens in within the context of a Kubernetes cluster. And like every other cluster, you have a master and you have some worker nodes, or you have you have your main one, you have your couple worker nodes. That's the same thing with Kubernetes. If you look at this image right here, the middle node right here is the master, and all around it are these worker nodes. Now, the machines are called nodes, and we'll talk about this in another slide, but a node can be either a physical machine, can be a virtual machine, either or. You can actually deploy a couple VMs on, let's say, for example, Azure. You can deploy a couple VMs, and you can have a couple of worker nodes being that, running you can have some of your worker nodes on-prem. So you can have a hybrid kind of solution. But regardless, when they're talking about a node in a Kubernetes cluster, they're talking either about a VM or a physical machine. Now, the master node controls the cluster. It's like the brain of the cluster. It's in charge of distributing pods, which you talk about distributing work. If it needs to be scaled up or scaled down, it's in charge of that. The worker node just do the work. So let's go to a couple more definitions. So again, a node runs the containerized application. It can be a VM or physical machine. And now a pod, as you see here, a pod is the smallest logical unit that Kubernetes has. Now, what is a pod? A pod runs on a node, and a node can run one or more pods. Now, one thing is, if you feel confused, don't worry about it. The next image I created will hopefully elaborate on the meeting. I remember when every time I read this, I have to slow down because I kind of confuse myself. It's kind of like those Russian dolls. You take the big one and there's a small one inside. It keeps going until like a little tiny. That's what some of these concepts are. So let's go to the next slide. Hopefully it'll shed light and explain what I'm talking about. Let's start from the left side. And I aptly call this the flow. I suck at naming, but the flow. Let's leave it at that. The image file on the left-hand side right here is, let's say, your SQL Server image file. It can be anything. So let's say it's your SQL Server image file. And then when you instantiate that running on your Docker container runtime engine, there's a command that you run, Docker run whatever the image is, and then it instantiates it. It creates it, is running. Now you have a running SQL Server instance in a container that you can access to very easily, just like you access with SSMS or Azure Data Studio. Same way, just like that. Now, so this container is this running image. Now, these blue objects right here is where we start getting into that Kubernetes cluster. So you can have multiple containers in a pod. Now, remember that a pod is the smallest unit that Kubernetes deals with. Now, Kubernetes doesn't handle or doesn't control the container. Let's say if you got the container, Kubernetes is not going to come and control the container itself, like these shipping docks right here. It's going to wrap this container in a pod, and then it deals with the pod. So it wraps it with the pod, and then it handles everything via the pod. Has nothing to do with the container. And you can have multiple containers, like I mentioned, in a single pod. Now, ideally, and this is the way you do, you have this like services, or if you have a service, in this case, which we'll look at later in a couple more slides, big data clusters, you have SQL Server, you have Apache Spark, you have Hadoop services running all on the same pod. So if that pod were to die, for example, for some reason, you don't worry about all the different services on that pod also dying. So if you have, for example, I'll give you a quick example. If you have a container running your web app and your database app, your database application, not a good idea. Because if the database goes down, the application goes, everything goes down. You want to kind of divide them up. So like services that you don't mind being terminated all at once, go all in a single pod. Those containers go in a single pod. So another example is if you have a SQL Server instance, and you'll see later, you have a logging or metrics collection container running also. So if you look at the pod, inside the pod, you'll see SQL Server service running as a container. You'll also see, for example, a logging container running. That logging only is needed if the SQL Server is running. If it dies with it, that's fine. Those are how you have the like services in a single pod. Now you have multiple pods on a worker node. Again, the worker node being the VM or the physical machine, and then you have multiple VMs in the cluster. So hopefully that made sense. If you have any questions, feel free to ask. Or even reach out to me later, and I'll be more than happy to further explain. So all of this that I talked about, Polybase, enhanced Polybase, containers, Kubernetes, everything. The question that I kept asking myself was why? Why is Microsoft going down this route of really changing the game? I want to understand before I get up for my lazy butt on my couch or my bed or whatever and dedicate 2 years of learning this and being able to speak to you about it today. And the question is why? So I want to share with you a couple of pieces of statistics that I came across that were jaw-dropping, and hopefully it expresses the point to you all as well. Let's start with this one. Data never sleeps. 90% of all data today was generated in the last 2 years. Now, this statistic actually was a couple years ago, so God knows what that number is now, maybe 93, 94%, whatever. Usually when I give this talk, this presentation to people, I ask them, what do they think this data is being generated from? What is generating all this data? And the overwhelming choice or answer is social media. Social media dumping all the Twitter, Facebook, everything. And that's just mind-boggling. That it is just like exponential growth and just keeps growing. Why do people need this? So what? Again, the question is why. Let me share with you another piece of statistic that'll probably blow your mind like it did mine. Give you a second to digest that. So Walmart, everybody knows a Walmart. Walmart is one of the biggest retailers. This is just one retailer, again, in the retail industry, right? We're not talking about agriculture or any other industry. We're just talking about the retail business. Walmart, they collect 2.5 petabytes of data from 1 million customers every hour. Every hour. And you might be wondering, what the heck is all that data? Right there, billions of Facebook messages, tweets, YouTube, videos, blog posts, whatever. You might not think that they're collecting data on you. They are collecting data on you. And by the way, Walmart has data on over 160 million people. So just 1 million customers over every hour, just 1 million customers. What about the 160 million? So this is where things started to shift. Okay, amazing. I wanna share a quick story, and this is true with Walmart, that they found out through collecting all this information. This is just a sample Facebook tweet. They do weather, they do every stock item in Walmart. They get the weather, the time that it was delivered, the shelf, everything that I can't even think, everything that you can think of about this, they collect all this data so they can run algorithms on and start do predictive analysis and stuff like that. They found out that during a certain time of the year, actually during hurricanes in Florida, they noticed that sales of Pop-Tarts was spiked by 7 times. So it'd be 1x, 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 and whenever there was a hurricane in Florida, 7x. Specifically, strawberry Pop-Tarts would spike in sale. So they found this through all this analysis of all this data that they have. And now what do? Every time there's a hurricane in Florida, they push you strawberry Pop-Tarts front and center. So it's about maximizing profits and minimizing loss. So, okay, that's cool. Here's a quote from Walmart CEO. And this is the last slide on statistics, I promise. Give you a second to read that. This is the Walmart CEO in 2013. He's pretty much saying he wants to find out who everybody is, what every product is, and then connect them in a transaction. And if you ask me, you can replace Walmart CEO with Mr. Evil from Dr. Austin Powers, and it'll probably seem right. That's just amazing. It's incredible. He wants to find every product and every person and connect them in a transaction. All this, okay, still, why? Now we start to get into what big data clusters are and what SQL Server is. Now it started to, I had that aha moment with when Microsoft was pushing down this whole new paradigm shift with SQL Server 2019 and big data clusters. So it's kind of like SQL Server is saying, hey, you want to analyze all that data? You want to be able to report on it? You want to be able to collect it? You don't have to get anything other than a big data cluster. And they're saying like, pick me. Now the question is, what is a big data cluster? Now we're going to go to the definition. And this link here, this is taken straight from the Microsoft documentation on big data clusters. But very briefly, BDCs or big data clusters allow you to deploy scalable clusters of SQL Server, Spark, and HDFS containers. Now remember, on Kubernetes. So Kubernetes is the scaling, right? And the containers are the different services. These components are running side by side, right? To enable you to read, write, process big data from T-SQL or Spark, allowing you to easily combine and analyze your high-value relational data with your high-volume big data. So it's turning SQL Server from just your OLTP, little database. I don't want to say little, but confined to just OLTP, to all of a sudden you're an artificial intelligence machine learning platform, end to end. Starting from the left here, you're ingesting all different types of data, unstructured or structured. How you ingest it into HDFS, up to you. They store it, whether it's in relational or non-relational HDFS, or is SQL Server data pools. We'll talk about that. And this is where you get the smart people. I like to say the data scientists. They come in here and they start to prep and train their data using the machine learning services, Spark ML, and then they model it. They give it to you. You come in with Power BI, BI tools, and you just start to analyze. All of this is on a SQL Server. When I fully comprehended this notion, I started to get very excited. This is awesome. So if you all have been working with SQL Server your entire career or your entire professional career, you don't have to start from scratch per se. You don't lose sweat equity. You're still a SQL Server professional. You're adding on top of what you already know. That's one thing I wanted to stress. So let's talk about the architecture. When they talk about big data clusters from a bird's eye view, this is what they're pretty much talking about. Now, I took this is straight from Microsoft's documentation. They probably have some type of newer version of this image. All I did to this image was I bolded the black, the red, and the green so it can stand out a little bit for you. Everything within this green is the big data cluster. You have your application pool, your compute pool, your storage pool, your data pool, and your SQL Server master instance. One thing to note is this black on the upper left-hand side, this controller piece is actually part of your big data cluster. So everything is inside here. Everything outside like this, these are your apps that are coming into your master instance. We'll talk about each one of these components in the next couple slides. You have your data sources coming in, IoT, whatever. We're going back to the Polybase connection in terms of different data sources, for example. They're all coming in and being cached in a data pool or stored in a storage pool. That is your big data cluster. Now, SQL Server has expanded, has took advantage of the technology of Kubernetes and containers on Linux and built this type of beast for you. So let's go on and start talking about each one of these individuals here. Before I go on, this one thing I want to note is the SQL Server master instance is the only endpoint, the only entry point that, let's say, you and I as a data professional log into. We don't log into the compute pool, the storage, all the other nuts and bolts inside. Microsoft has done a great job actually abstracting that away from us. You can use command line tools to look at what's going on, but you don't have to log into it. We log into the master instance via SSMS or ADS, and we do everything. Everything else happens in the background. So let's go ahead. The controller piece is a couple pods that run a couple services or containers in there. They have and it does the deployment of the big data cluster. It handles interaction between Kubernetes and SQL Server. So if you're deploying a big data cluster, after this, you're like, you know what, let me go ahead and deploy a big data cluster. And you try to do that. If you fail for some reason or not successful on the controller piece, which is the very first thing that's built when you deploy a big data cluster, then you have to start from scratch, or you have to figure out why that is. You cannot, if the controller doesn't work, nothing else works. So Microsoft actually has integrated open source tools like Kibana and Grafana. If you were to go look up Kibana and Grafana, they're just metrics and logging tools that are free. They have dashboards and everything. It's just beautiful. So much information, and it's all free. So again, the controller provides functionality, manages cluster lifecycle, deleting, updating, things like that. Manages compute data and storage pools. We're talking about that, the master instance, and cluster security. The master instance, like I mentioned, is the only entry point that you and I log into. You can log in via SSMS, or Azure Data Studio. It's in charge of the scale-out query management. So that means if you are writing a query, you got a couple of joins in there, or you're reaching out to an Oracle server, Teradata, or anything else. Based on that algorithm, it decides, okay, maybe I should push this compute to the compute pool. So the master instance isn't busy doing that. The compute pool handles that and returns the results back to you. So it's the management of that, the query management, is handled by the master instance. Machine learning services is on the master instance. Compute pool. Now the compute pool, like it says, it handles computing. So the red right there are these instances of SQL Server. So these pods that are running SQL Server. Now you see there's 3 instances of that. You can deploy multiple instances based on what your needs are. So if you're doing a lot of computation, you can scale it out. You can scale it back in. That's the beauty about Kubernetes and this integration with big data clusters. So for a compute pool, the pods in the compute pool are divided into compute instances for distributed queries, mainly, specifically, Polybase. So again, if you're doing Polybase joins with other data sources, it can get pushed onto the compute. Master instance is relieved of that pressure, it can do other things. The data pool. Now, one thing I want to say is when I mention a pool, that's just a logical unit of like services, no big deal. You don't. All this is configured in the background. So when I say a data pool, all it is pods that handle the data pool stuff. That's it, or a storage pool. So you have a storage pool. The pods in the storage pool are not going to be doing anything in the data pool, for example. They're separate. So data pool is used for persistence and caching. So for example, if you are a SQL Server DBA, your manager comes up to you and says, you have to reach out to this Oracle server and get some data on a one-time basis, whatever. You have an ETL job or something, getting all this data all the time is going to this Oracle server, get data, bring it back in. But for some reason, this Oracle server is sitting on an old hardware, slow network bandwidth, whatever, and takes forever to do your select from it. You can do that one-time select, cache it into your SQL Server data pool, and then you just go and query that again. You don't need to worry about the Oracle server. You just have to reach out to Oracle server if you need something fresh or whatever. But so you can persist data to the data pool, and it's used for caching for your queries. So a storage pool is where you're coming with HDFS and Hadoop. So if you have your Hadoop HDFS pods integrated with SQL Server and Spark, and you got this data coming in, unstructured data, you can dump it right into the storage pool. So this is your, again, your collection of data, your storage pool, or your pods that are handling, or they're running HDFS, SQL Server, and Spark services. Like we mentioned in my flow, quote unquote, flow picture, I had Spark, SQL Server, and Hadoop. This is where that happens. So all the pods have these different services, and they store your data from Hadoop. Data ingestion through Spark, data storage in HDFS Parquet format. So this is a format that is unlike CSV. I urge you all to do a quick look up CSV versus Parquet format. And you'll see for HDFS, they can read a large amount of data via a format of Parquet or Parquet format. HDFS data is spread across all the storage nodes in the BDC for persistency, and data access HDFS and SQL Server endpoints. So you can still access this data, but you access it via specific endpoints. Now, I remember when my a mentor friend of mine introduced me to Kubernetes, and this was probably coming up to 2 years ago, and he mentioned that Kubernetes can do this, can do that. Just imagine if a SQL Server instance goes down in an AG, an availability group, one of the replicas or whatever goes down, Kubernetes would automatically bring this back up. And he was throwing me a vague description, but I understood. And as soon as he said it automatically would come back up without me having to intervene per se, I really like that because I'm pretty lazy. And if something else if a machine can do it for me, the better, right? So I got so excited. I reached out to my friend that actually got me into doing DBA work in SQL Server back 11 years ago. And I called him up, older gentleman, old school. I called him up. I said, hey, do you know, have you heard of Kubernetes? He said, no. I was like, okay. And then I was so excited. I told him all about it. I said, it can do this. Imagine if your replica goes down and Kubernetes will come and bring it back up and blah, 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 blah. And he said, okay, what about the data? I'm like, dang, I didn't know. So I had to go back and keep looking. So how SQL Server has a database professional, data is huge. We can't just, we have to know where data is stored, right? So with Kubernetes, the way storage works is via this concept called persistent volumes. Now, this image right here, taken from AKS, or Azure Kubernetes Service, Microsoft documentation, and very, very roughly, imagine you have your cluster master, going back to your Kubernetes cluster master, right? And then you have your worker node. And then at the bottom here, in this case, we're talking with Azure, we have managed disk and Azure files. We present this storage to the cluster, to the Kubernetes cluster, as a persistent volume, right? So we code that into the cluster, and we code that into the node, and we say, oh, by the way, this file path, or this path to the storage block right here is a persistent volume, meaning that if this node were to die or something happens to the master, the storage will still be there. Don't delete the source. Storage is gonna be there. It's persistent, right? So the cluster master says, okay, it's a persistent volume, this storage, good. And it keeps it as a persistent volume. Now, this node or this pod specifically, let's say SQL Server pod inside the node, has to create this persistent volume claim, and it requests that storage from the master. And it says, hey, I need 100 gigs. I need 500 gigs. I need 10 gigs, whatever it is. Here's my persistent volume claim. The master looks at that claim. It says that, okay, it's good. It matches up. It binds that storage to that pod, and that's it. It's good to go. Now, I like to view this as DMV. My license actually being coming up to expire June 3rd. And I don't know what I'm going to do because everything's on lockdown or whatever. So hopefully they extend that. But anyway, you go to DMV and you get your ticket, your D547 or whatever. You sit down and you're looking up at the screen and you see D50. You're like, I'm going to be here for like all day. Now that ticket is considered like the persistent volume claim. Now you don't got to wait that long to get your storage. But the master is like, if I went up to the booth, finally when they called my ticket number, I go up to the booth and I give them the ticket. Then they help me. They give me service. The pod is giving the master the PVC or the persistent volume claim or the quote unquote ticket. Then once it's accepted, then you get your storage. Now, if I go up to the DMV booth and I don't have the ticket for some reason, guess what? I actually never had that happen, but I can imagine they say, you got to go get another ticket and go to the next person. So that's how storage works. So Kubernetes doesn't really have storage per se, more so than it makes sure it orchestrates that storage. So we're talking about persistent volume and persistent volume claims. Now, for the sake of it being, if you were to download this presentation later so you can make notes and take notes or whatever, this is the verbiage, pretty much what I just been talking about. So BDC endpoints. There are a couple ways to get into the SQL Server Big Data Cluster. Now, the orange one that you see right here, is the Azure Data Studio, SSMS, ODBC, your regular connections. If a data scientist comes up to you, I need the endpoint to get in, or a developer, or you need to log in, or you need to have a connection string for an application or whatever, all that happens, you give them this endpoint right here, regular SQL Server TDS endpoint, you give that to them. Everything else is specific to the service or the service that you're trying to look at. For example, starting on the left, AZ Data CLI, you download that as a command line interface. You can do a couple command lines and you can look at the controller. You can do troubleshooting, you can deploy the big data cluster, all that you can do via the command line, AZ Data. Again, you can use Azure Data Studio, all these other services to look at the gateway, management proxy, metrics and log dashboard. So when you actually deploy a big data cluster, you're done deploying it. It takes some time, has to deploy all this. You are returned a list of endpoints. And two of those endpoints, one is for Grafana, one is for Kibana. If you click on those, it'll bring up your browser, your internet browser, and you log in with the credential that you use to create the big data cluster. And you look at the wealth of information and actually the beauty of it. For example, Grafana, I still can't imagine, there's so much data there. And again, this is all free. And these are services that come as part of deploying a big data cluster. And then for the app proxy, you can install VS Code, Azure Data Studio, and AZ Data command line interface. Now, when I usually give this presentation, I can see everybody. I ask them, how many people use Azure Data Studio? And not that many hands go up. But when you want to deploy a big data cluster, I advise downloading Azure Data Studio and getting used to it. And it really, really helps. It really have a GUI walkthrough. So you're not going from like your Windows background to all of a sudden AZ Data command line interface. Like, oh, what am I going to do? Azure Data Studio is a great download. They actually released an update that makes it a little bit more easier to deploy a big data cluster. So I highly recommend, if you have not downloaded Azure Data Studio, do it. And you will, again, reach out if you have any questions, but it's a lot better. There's a lot of things you can see besides just deploying a big data cluster in Azure Data Studio that you still cannot in SSMS. So all this is just a verbiage for you if you were to download. Now, features. The one feature that I absolutely blew my mind, and it's funny because when you look at it back, they say hindsight's 20/20, but when you look at something that I initially found out about, let's say a year and a half, 2 years ago, At the time, I was super excited. Now, since I guess I've been used to it, talking about it, it's not as exciting, but it still is. It still is very, very exciting. So data virtualization, this concept right here just really lifted me. It gave that fire in me to go pursue big data clusters. And this whole notion of having a data hub that you can sit from your SQL Server and using this enhanced Polybase, you can go and get all this data from different data sources, bring it back, and have this virtualized layer, so to speak. And this is where this concept of data virtualization or this data hub is. You can query all the different data, and you're at SQL Server. This really blew my mind, and this concept right here is what really, really got me and passionate enough. I mean, again, I'm a lazy individual, so if it's something that I'm talking about, it's something that I'm very, very passionate about. So notions like data lake, right, where you have all the different incoming streams, so to speak, and then you have your HDFS storage pool, for example, you have all this data coming in, and you have different personas. You have your DBA, your developers, your data scientists coming in and querying their silos of data or their quote unquote data marts, right? And all within a SQL Server. I mean, this, again, it blows my mind. All within SQL Server. All this is happening in the background. This really, really is interesting time for SQL Server. One thing you've probably been thinking is like, okay, so he's talking about Kubernetes, he's talking about containers. That's cool. He scale out, blah, blah, blah. That's awesome. Data virtualization, cool. Storage, persistent volumes, persistent claims, so we don't lose the storage. That's all cool. But how much is this going to cost me, right? Now, this is either very, very interesting or very, very boring, and people go to sleep when it comes to licensing. So I try to cut a lot of the, sleep-inducing stuff out of this and keep it to the basics. So BDC licensing, every single instance that you saw requires licensing. So what's Microsoft going to do? So BDC licensing, master instance must have core licenses. So if you remember that master instance that we all log into, let's say it's a 4-core node, you're going to need core licenses on that. And that's a price for enterprise versus standard. Again, licensing is a very complicated topic, and you deal with your account managers and stuff to kind of get specific deals and stuff like that. But this is just taken from the Microsoft licensing guide. So software assurance, what's the benefit of software assurance? This is where really you look at Microsoft really has done a great job in terms of making it appetizing financially to adopt big data clusters. Is every single one of those pods or nodes that require cores, those SQL Server instances, let's say your storage pool, your compute pool, your data pool, you can get those as part of having software assurance. You get something called an entitlement, or a BDN, big data node core entitlement. And what is that entitlement? That entitlement is $400 for a 2-pack of core per year. But what does that mean, right? So let's look at an image. Let's start here with enterprise licensing. If you have software assurance, whatever cores you have on your master instance right here on the top, you get 8 times that as your entitlement cores that you can distribute among your other nodes, like the storage pool, compute node, data pool, stuff like that. So in this case, you have 4, right? You have your 4 core licenses, 4 times 8, 32. So you have 32 cores that you can distribute among these other instances of SQL Server. And then all you're left with is these right here, 16, that you have to pay $400 a year subscription for 2 cores. That's actually pretty cheap if you think about it. That's pretty interesting right there. So when they came with that $400 price, that's very, very cheap. So that's enterprise. What if you have standard? Pretty much the same thing. Well, not the same thing. Instead of 8, it's just 1. So if you have your 4-core licensing right there, you have your 4 times 1, you get 4 BDN cores. You're entitled to 4. You can just cover that right there. And all the other ones right here, you'll have to do your licensing, that $400 a year subscription. That's cool again. And as I mentioned in the beginning, you can have a hybrid solution. Of course, it's all based on your needs and security and all this other stuff. But how does Azure work? Azure, very simple. Whatever you have on-prem, you put it on Azure, like it's quote unquote license mobility. Just take it right there, and you're good to go. Now, one thing I wanted to say is that the learning curve for this is steep, but don't fear. This, I believe, and I've said this numerous times on Twitter, I've tweeted this, I've blogged about it a couple times, is that I believe the future of SQL Server is this. Not necessarily big data clusters per se, but this notion that you have this integral part of big data and relational data. However that is, that's the new SQL Server. SQL Server is not going back. You go back to the exponential growth of data, in terms of data never sleeps 90%, is only going to get bigger and bigger and bigger. So I want to leave you all with a learning path. Now, these are just things that I have been reading up and doing along the way, along this last year and a half, 2 years. And I've said it as much as I can. My call to action to you is head on over there. You'll find this session as a PDF. You'll also find a bunch of blog posts. And also, I think a couple months ago, I started a YouTube page. I have a bunch of BDC videos on that. And it's been kind of rough with the schools closed, and I got a couple of kids here. So producing content like blogs and videos has been kind of taking a slow, kind of dial it down a little bit. But I plan to pick that up fairly quickly with the videos, especially to show you how to do things, how to deploy stuff, walk you through things, all that you'll find there. There's an Excel checklist right there you can go download, and things that I've used, for example, Linux containers, Kubernetes, free, there's paid, there's books, there's all types of things there. And again, reach out to me. If you want to give feedback to this session, that's fine. I love it. Reach out to me. Again, my blog there, I really do appreciate it. And thanks, big thanks to Tim and Microsoft and all the people out there, actually including me, and this lineup of great speakers coming up for the next couple of weeks. I do appreciate it. If you have any questions, feel free, reach out. Or if you think of a question, you're like me, you think about the question when it's too late. Don't worry, reach out to me on my blog. A lot of people reach out to me, ask me all these complicated questions about BDCs, and I'll get back to you. So time for questions. Go ahead and shoot.
All right, got any questions, guys, about SQL Server 2019 big data clusters? It's a lot of information to take in.
It is.
Storage and the processing layer, the compute layer, Kubernetes containers, and all of that stuff. We'll just make sure we leave this slide up, because I did post the link to your slides and your blog in Twitter and in the discussion area, and for Meetup, the main page for NovaSQL, and also the specific Meetup for today. So everyone will be able to get to your slides, and then I tweeted all the information out as well.
Awesome. Thank you for having me.
Well, okay, guys, if there's no questions, wait. Here we do have a question. It's from Mustafa, and the question is, all data should be stored on Azure service, can't host the data locally?
So I'm assuming the question is that his requirements are to have storage only on Azure. Is that the question? And can he still deploy a big data cluster? If that is the question, yes, you can. You can deploy a big data cluster using AKS to do your clustering. You can still have it on Azure. That's not a problem. There might be some issues in terms of getting those disks, that storage that's currently in Azure, to be persistent volumes and kind of integrate that with the Kubernetes cluster. But yes, you can eventually do that. Absolutely.
And you can fully deploy a SQL 2019 big data cluster on-prem, but you can also have the virtual representation of that out in Azure, right?
Yes.
Okay.
Yeah. I actually have a couple blog posts on how to actually deploy a big data cluster on AKS. Fully, it's 100% on Azure. That was like a 4-part series to break down and do that. So that was actually my first foray into big data cluster, deploying it on AKS.
Gotcha. So, we got a question from Kevin G. It says, you mentioned that the future of SQL Server is BDC and what would be the other thought around that?
Just a correction. I'm not saying that the future of SQL Server is specifically BDC, but what I am saying is that the future of SQL Server is this ability for SQL Server to process big data and relational data, right? So right now that is BDC, and I'm very close with the BDC product team at Microsoft, and it's not going anywhere. Right. In fact, there's so many features. I mean, this will be. So if you're just a DBA or you just have relational experience with SQL Server, to get on this quote unquote wave, right? To get on the wave of learning big BDC and all of the underlying technologies with it will put you make you relevant for years to come. Let's put it like that.
Right, and Ayman commented it's the polyglot persistence model.
Yes. Yes.
So multiple data sources, multiple sizes of data, be able to process, like you said, Mohammed, big data and relational data, all the same query, all the same workspace.
Yep. Yep. Within SQL Server. Yes.
That's right. Anybody else have any questions, guys? All right. Got some good thank yous in there and some got thank yous about your original question. So we'll go ahead and, oh good, some more thank yous. We'll go ahead and wrap it up. And go out to Mohammed's blog at mohammeddarab.com/BDC or /feedback, or hit him up on Twitter. And we'll see you next Friday for another of our Friday webinars. Thanks, everybody. Thanks, Mohammed.
Thank you. Thank you for having me. Take care, everybody. Sure. Stay safe.
Sure.
Bye-bye.
Bye.